Welcome to workshop day of Samvera Connect 2018. This workshop is enhanced media playback in Hyrax using Avalon components. So if this is not the workshop you signed up for, you can go leave or stay and be pleasantly surprised. My name is Chris Colbert. I'm from Indiana University. I work on Avalon Media System, and helping me today will be Brian Keese, also from IU. Just a show of hands, is anyone who was able to go through the instructions in the email and do the Docker start stuff? Okay, so for those that haven't, I'm gonna blow this up. If you can now, I guess if you have received an email from me, if you haven't, I guess I can, maybe Brian can help get you this information. This is on GitHub, Avalon Media System /Connect 2018-workshop is the repository, and this is just in the README. But you should work on getting Docker and Docker Compose set up, and this clone, and then running the start sh, which will download the Docker images, which will take a while because they're fairly large. It's going to set up our whole stack. So you might want to kick that off now during the kind of presentation phase of this workshop. So that way you'll be ready when it comes to the workshop part. And if it's not working out with Docker and Docker Compose, people can pair up later and we can work together. So I guess if you ever need help on during the presentation part, this presentation phase, if you need help with the Docker setup, raise your hand and Brian can help you with that. So we're going to have kind of three phases to this workshop. Since we have 3 hours, we have until noon at lunch. We're going to have a kind of a presentation point where I'm going to kind of give you background, kind of how we got to this point, and then we'll take a short break. We'll then come back and work with one of the plugins, one of the Avalon components that we're kind of presenting here. And then we'll take a short break and we'll come back and do a second one. Any questions at this point? Feel free to always kind of just raise your hand and shout out questions. And I guess we are recording, so when we do questions, we'll have a microphone so we can capture your questions and preserve it. Okay, starting off with just kind of what is Avalon and what's some brief history. I'll just try to speed through this so I'm not talking at you too much. But Avalon kind of has a long history. It's been one of the first Hydra and now Samvera, I guess, solution bundles. It kind of grew up at the same time as Sophia, if you've heard of Sophia, which is now evolved into Hyrax. And it was really focused on audio and video delivery of access, not necessarily preservation, really access to AV content. It's always been a partnership between Northwestern University and Indiana University. We have some of our Northwestern pals in the room. And there are current implementations at other institutions outside of Northwestern and IU. Here's some of them. I think this slide is probably mostly accurate. I think this slide's coming from presentation at OR, so it should be pretty up to date. And Ryan can talk for hours on all of the stuff other institutions are trying to do with Avalon. Avalon development has gone through a number of major releases. Just kind of looking in the past couple of years, Avalon 5 added a lot of features, including playlists and better support for kind of bulk ingest. It added caption support and a few other things. Avalon 6 was really just a port of kind of the backend onto Fedora 4, which if you're familiar from Fedora 3 to Fedora 4, it's a really big change in terms of switching from our mostly all XML metadata to mostly all RDF with some XML still, switching from Fedora 3 to LTP in Fedora 4. So that's where we're at currently, I guess. Our current releases are this Avalon 6x branch. Our future work and our work that we've been starting on, part of what's going to be in this presentation is this work on what we're granting Avalon 7, and where we're kind of trying to take the stuff we had done in Avalon 6 and bring it on top of Hyrax. Yeah. Yeah, we're getting there. So Avalon 7 being built on top of Hyrax, we've kind of envisioned it as a set of plugins, a set of components that can be plugged in on top of Hyrax. So a lot of the functionality that might exist in Avalon isn't going to necessarily only live in Avalon. It could be useful outside of Avalon to other Hyrax apps that want to do AV content in a more Avalon style as opposed to what's currently there in Hyrax. So here's like kind of our slide we presented at last Samvera Connect, showing kind of one vision of what these plugins might look like. So one for IIIF player and like playlists, LTI integration, which is working with learning management systems, and some like ingest API, and then of course our like Avalon work type, which might be wrapped up as a plugin or might just live within our Avalon app. So we've started on this work, and I guess what we're working through this workshop today is a lot of what we've done, just minus the work type, which there will be a presentation on later. Samvera Connect. Yes. LTI is learning tools integration, and so this is a way for within a learning management system like Canvas or Blackboard to link in external tools. So how we've used it in Avalon 6 is mostly through authentication. So we at IU we've done a lot of course reserves through a previous system called Variations that migrated onto Avalon. So instead of having to manage course rosters and that kind of to remember it's like FERPA, like protected information, instead of having to deal with that within Avalon, which we had to do within our previous system, Variations, it's all kind of getting managed within the learning management system, and then a connection within the learning management system. When they try to access Avalon, there's like authentication tokens and stuff, kind of OAuth, that gets passed to Avalon, which allows them to log in and see course reserves, see stuff that's available, that's been put on reserve from Avalon for that course. Is that okay? So again, some of those components, some of those plugins, IIIF player, transcoding and streaming support, which is kind of the other component we're going to talk about in this workshop. And then kind of building on for that later, we'll get around to these other components that we haven't worked on yet, which is, again, playlists, our take on leases, which, again, from a more kind of course reserve use case, being able to grant someone access to an item with either to a particular individual or to a group for a limited amount of time with a start and end date, which is not available within Hyrax currently. I mentioned LTI, and then some sort of ingest API, which might be coming through the Hyrax batch ingest working group that's already been started. Okay, so getting into IIIF. So this is kind of the first component plugin piece that we're going to be working on later. So background on IIIF. Who's familiar with IIIF? Most people? Good. So IIIF here is defined as a community that develops shared APIs, implements them in software, and exposes interoperable content. So it's kind of all of those pieces, right? It's the APIs, but then also kind of software implementing those APIs, and then the content that's also conforming to that API and getting shared and usable in an interoperable way. You see that it has image in the name of IIIF, and so kind of where, as well as interoperability. So it's the interoperability part. If a lot of software is conforming to that API, then there's a lot of benefits from that. Many different servers can supply stuff conforming to that API, and then many clients, and here I'm talking probably mostly JavaScript clients, that can consume it and render it within a browser context. You're not locked in to, within Avalon 6, we built up this player, and there's a lot of kind of interactions with our player that's really specific to our application. It's only really usable and makes sense within our application. And instead of kind of maintaining that kind of tightly coupled thing, if we were to change, we changed or upgraded our player at one point, and we had to go back and rewrite a lot of stuff because it was just so tightly coupled. So the IIIF API, the presentation API specifically, allows kind of that abstraction that allows you to have a shared contract between your JavaScript front end and your content, allowing you to switch out kind of your player, your viewer more easily. And that last point is really, kind of like the promise, and is really interesting of being able to take content that's been shared at one location if it's public, and content from another location that's public, and pull them together within one viewing experience that's very well defined because they're conforming to this API of how to share the content. So I won't dwell on the image API because most people are already familiar with IIIF, but this is what it looks like for images, kind of how it started. Is let's make an API that says just kind of how we can transform an image. And this was allowing for tiling and deep zooming and lots of kind of neat functionality when before that was maybe, again, implemented particularly for one application or was not really possible. You can take a look at Mirador, see if this works. So here's a IIIF viewer. It's taking content exposed by some repositories, and it's using the image API to render these images. And these are coming from 2 different repositories, and we can, there's metadata here attached to this image. There's this kind of beautiful deep zoom you can get. And yeah, it allows, you can do annotations. And so these IIIF viewers are very rich and kind of allow for just really deeper interaction with the content. So the image API allows you for manipulation of images. The presentation API is what kind of bundles or wraps around that and adds in metadata, either descriptive or structural, kind of a navigational metadata, and really allows for this, not just interacting with one image, but again, this rich experience. So here's another, I guess, example within a context. Here's a musical score, this time within Universal Viewer, another IIIF viewer. And this is migrated from our old variation system that dealt with scores and audio. There's zooming. Here's some of that structural metadata for navigation. And over here is some of our descriptive metadata. Okay, so how does this apply to AV content? A couple of years ago, maybe a little bit more, there was a group formed to try to work through, like, how can we extend this richness, this what's grown up around the image content with IIIF that seems to be working really well. How do we extend that to AV content? Because AV content now all of a sudden adds like a third dimension. It adds time, and everything within the API was height and width, and really dealing with the use cases of images and paged content. So what's kind of come out of this group that's met a few times and worked through resolving issues in the spec, there's ongoing calls, is the presentation API version 3.0, which is in an alpha or beta state right now, but it's pretty settled. Thought it's supposed to be kind of full ratification of it maybe near the end of the year or early next year. And kind of some of the core points, differences from the previous one is, again, this thinking about time-based media and not just thinking about image content. And so that kind of runs through the spec. Okay, so what does a presentation API implementation look like? A server will respond to a request for a manifest by returning the JSON LD document. And there's this entity graph over here, which you don't need to pay attention to too much, but really the main thing is it's a manifest. This is called sequence here. There's no longer sequences. That's kind of confusing. It is items instead. There's a canvas, and there's content that's kind of painted or rendered onto that canvas. This kind of canvas concept, the shared canvas, allows for annotating, kind of painting onto it various different things. In the past, it's images. It could be regions of images and composing those to, say, join up. Kind of classic example, I think, is illuminated manuscripts, where they've old medieval manuscripts that have been cut up and have been redistributed. So someone has like a beautiful illuminated first letter, and someone else has the rest of the page. And so those can both be served by the image API, but to kind of bring them together to reunite those pages without having to physically have them scanned together is to implement this kind of shared canvas where you can paint those two different pieces together onto the same page. So the shared canvas concept still exists within time-based media, just now you've got a timeline, and you can paint stuff within certain time ranges as well as XY coordinates. So how does Avalon perceive using IIIF? And here's some of our use cases I'll just run through quickly. So Northwestern's Avalon instance has archival film like football games, which I think they have a lot of that content, as well as IU would. So this is just kind of archival film that we'd want to show. Pretty straightforward, not too much there. Just one film, one video painted on. We might want to be able to integrate licensed video content if it's distributed within a IIIF format. We could integrate that in, or we might be able to expose our content if it becomes a shared database or something. Here's another example of archival collections. We have another system at IU that's finding aids, the EAD finding aids, and providing links to our content from within that. It could become an embedded player potentially within that context. as I already mentioned, kind of course reserves that could be in within a learning management system. Here's actually the example of what that looks like. So here's Northwestern's Canvas learning management system. So a student would log in and see their classes. They would go to their class, and there could be something like this, a link to library media, which would immediately log them in to Avalon and show them their reserves for that course. That's kind of what's going on here. There's already a facet applied saying within this course that has a kind of authorization group, just display those things. Other use case IU has for kind of all this AV content is there's been a large effort to mass digitize basically all AV content on campuses, or mostly all interesting. And I think most of the digitization is wrapped up on that, and it's around 250,000 items, which could be a single VHS tape, it could be a LP with 2 sides, it could be all kinds of content. It could have multiple cassette tapes within a box. Online exhibits. Here's one that we've had that embeds Avalon content for World War II propaganda films, as well as kind of publishing online. We're sharing our content out of an Avalon instance for online publishing, as well as online publications. Here's some Avalon players embedded within this online journal. So this is kind of the context of where use cases that we have that we're already using Avalon, and some of the ways that we're wanting to, and that's kind of feeding back into how we're designing our player and how we'll be using more and more trying to use IIIF for these contexts. Oh, sorry, and here's a few more. Here's a playlist, which would be used in a course. You can see it says it's an exam. Professor can set up a playlist with just clips with segments, and our general player. And yet another context, OHMS, which is a oral history kind of tool for creating transcripts and playing back and navigating with transcripts. There's going to be a presentation on this later, I believe. Ben Armenter and John Cameron will be talking about oral histories and their work on it. Okay, lots of use cases. So Avalon 7 and IIIF AV. What have we done so far? This is what some stuff we'll look at within workshop segment next is having the manifest endpoint. Hyrax currently will produce, as of Hyrax 2.1, Hyrax will produce presentation 2.0 manifests using the IIIF manifest gem. So work that we've done that's in one of these plugins is to produce presentation 3.0 manifests so we can get the richness and we can get the time-based media in there. We've made a kind of proof of concept, prototype IIIF player that will play AV content. That's not, it's not one of the other viewers. Universal Viewer already has some support for AV content. As part of proving out this spec and trying to think about how to make something that's very specific to our use cases. We've been making a player, and we'll see that as well. And future work, which we haven't done yet, is trying to re-implement playlists using IIIF manifests, which is really straightforward, I think. Now that there's some additional features provided by presentation 3.0. That's some future work. One thing that's not on here that I'm not sure if John Cameron will get to demo is there's been some work just recently on another pedagogical tool that we had in variations, which is drawing these bubble diagrams for kind of analyzing music that professors would use. We called it Timeliner. And that was a really popular tool that when variations was kind of dying out, we actually made a standalone one that we shared on SourceForge. So this shows you kind of the age of it. And we get reports from people around the world. It's like, oh, it's not working now. And we haven't touched it in, probably close to a decade. But it really is something that's valuable and useful. And so we've done work to, we've had some contracting with Digerati, which is another consultant that focuses a little bit more on IIIF, and to rebuild this around IIIF manifests. So hopefully John Cameron will get to demo that later. If not, ask us and we can show it to you, or in the future show it to you, because some of that initial work is just wrapping up. So this is a preview of what we're going to be doing in the workshop. Here's what this IIIF player looks like within a Hyrax context. Just really basic, just real basic right now. We're not doing anything with descriptive metadata or structural metadata quite yet within the Hyrax context. But here's our player. You can use a IIIF player within Hyrax. We'll see that later. Here's taking that same manifest. This one's, I think we handcrafted this manifest a little bit for the structural metadata. But that structural metadata is now here taken over into Universal Viewer outside of Hyrax, outside of our player, and we get the same functionality. We get the structural navigation, we get thumbnails and poster images, we get the descriptive metadata. And here's our IIIF player, but within its demo page. So you can go to this URL. I think this one works. It's Avalon Media System.github.io/Avalon-IIIF-player. I think this URL is still correct. We went through a few repositories. And plug in a manifest URL, one that's, it only really works with Avalon style presentation 3.0 manifest right now. So it doesn't implement the whole spec. But here you can see that same manifest taken over here. Another viewer, another player is rendering it. We got the video player, we've got the structural metadata, structural navigation. And Arlene has a presentation on Thursday, which I think will cover some of this, talking about using React components, but he was implementing our player using React. So he actually built an NPM package, and there's, that gets wrapped up, as we'll see in the workshop, and rendered within our Hyrax application, rendering a React component. Okay, any questions about the IIIF stuff before I move on to the next piece of transcoding? It's a lot of information, but just kind of setting the stage. We'll cycle back to some of this stuff. Yeah, okay.
You said you were hand editing the structural metadata, so I'm just curious to hear more about how you did that and whether you're planning to make that something that users could do within the software, or if you're hand editing it already in Hyrax somewhere, or how that works.
Yeah. For structural metadata, Avalon has a, I guess, kind of brought over from variations where we had a lot of structural metadata and had a way within that to, within the application to generate that. David's raised his hand. Okay, yeah, structural metadata being, I guess within like a DVD context, you think of chapters within a DVD. You've got one DVD, and you have it split up into chapters, and so you can kind of hop within it to those points. Within, sure, how far back here? within, this is a piece, CD that's brought over from Variations, and how they've done it here, we have a CD that has multiple works on it, and this is really common within classical music to have multiple works or pieces of works put together on one CD. It's not just one CD equals one work. So there's a lot of effort put into kind of segment that and to make it apparent, like kind of what fits to what thing. So here's pictures at an exhibition, which has many kind of movements within it, specified as one kind of structural node and with those tracks underneath it. But then there's these two other pieces that were also tacked on that are also linked there. So this shows a little bit our hierarchical structural metadata that we have coming from kind of classical music context. Another example we use a lot is opera, and saying an opera has many acts, within that has scenes, within that has arias. And so being able to drill down and see what fits in with each context. And this structure is different from structure that's in kind of IIIF Presentation 2, where you're working with paged content. There you're kind of putting together pages within individual files to build up chapters and books and volumes. Okay, but so sort of. I guess what I'm trying to point is that this is dealing with structure within a file, as opposed to structure of files, of multiple files. It's not only that, yeah, because you can do other things. But that's where it departs a little bit. The question of structural metadata within Hyrax. We have, so as an Avalon, we don't have a really good way of making that structural metadata right now. It's mostly hand editing. But we're currently working on building a tool to make it easier. Again, it's a React component that should hopefully be a little bit more shareable. But at first is really just going to be built for this Avalon use case. It generates, so we have in Avalon 6x is some custom XML that does this kind of hierarchy. And what we've implemented within our Avalon 7 under development app is a crosswalk from that XML to the ranges within the IIIF manifest. So that is implemented, but it really is coming from this very specific XML that we have starting with. So it'd be great if we can get to like a community tool that can build up this structure, kind of a manifest editor. No. At this point, yeah, I guess what we have is, since we're dealing with structure within a single file, we've kind of simplified and said we're not dealing with structure of multiple files. We're not really dealing with, and we're just dealing with structure within one file. What that's looking like is having that kind of custom XML document on a file set as yet another file. And crosswalking that, and I guess just within the ranges within a IIIF manifest, which hopefully we can look at later, it can just be one of those within the array. Each file set is going to spit out its range. Yeah. Do you want to do the microphone thing? It's going to be recorded, so.
Oh, I didn't know it was recorded.
Yeah.
So I don't want to sidetrack us too much, but is the choice of the React components a Hyrax thing or an Avalon thing?
It's an Avalon thing right now. Maybe David, if you want to, I guess Adam's going to have this presentation on Thursday, and David can maybe talk to it a little bit. It's David Schober from Northwestern. Donut is doing lots of React, right?
The front end is, right? I mean, we just, Adam Arling, I think you've met him, he's our front end dev. And he did a bunch of research and has expertise in various front end frameworks and kind of settled on React as a well-supported one that's very portable. So that was what that was really what, I mean, if that is the question why we decided to go that way? Or what was that?
It's not why, I was just curious if it was in, like, if you chose React because Hyrax had chosen React, or Avalon had chosen React. And we're hoping
Yeah, we chose it because we thought it'd be easy to plug it in. So all those things, I think in the future, we've already started moving in that direction. So hopefully if we want Hyrax to move in that direction, it'll make it easier.
So I think David is saying Northwestern's done some work within a Hyrax app to make their front end mostly React components. We haven't worked or really thought a whole lot about front end for Avalon 7, but it seems like we might go that way.
All the front-endy specific things are being released as packages that can be plugged into Hyrax or any other app. So including our player and the structural metadata editor that we're working on and a few other things.
It was relevant to our interest because our front-end stuff is new, so.
Okay. Yeah, I think I think what Adam is familiar with is React. And as I was saying before, Avalon 6 is just really like tightly coupled the front end JavaScript with Avalon. And yeah, we need something different, I think, is what we're deciding coming out of that. Any other, I guess, IIIF questions? Otherwise, I'll move on to transcoding, and we'll try to take a break at the top of the hour. Okay. So I should say Avalon 6 does transcoding. What I mean by transcoding is re-encoding the uploaded audio or video file and making derivatives of multiple qualities that we then stream out from a streaming server. And that can take various forms, but within Avalon 6 we generally specify saying we have a high, medium, and low for video, making MP4s of different bit rates, maybe resolutions, and then we want those to be put onto a server that can stream out HLS, a streaming format that will uses HTTP and will slice it up into small, like 10-second segments, and then a JavaScript client will know how to fetch those pieces and reassemble it. So this is maybe somewhat similar to tiling, but not exactly within the image context. So Avalon kind of from the beginning has always wanted to do this automated generation of derivatives and tracking of that, managing that workflow, and placing those files somewhere else. Not anywhere within our application, not in Fedora, just because we're talking about 250,000 items of AV content with all these derivatives. It's really, really big, and so those are. At IU, those derivatives are living on a kind of central IT managed streaming server, and our workflow process will drop it off on that mount, and then they have a Wowza streaming server which will send out HLS. That's kind of the landscape of Avalon 6 at least at IU. And when Avalon started way back, we decided to adopt a tool called OpenCast Matterhorn for kind of automating some of this workflow and trying to make it flexible and stuff. We found that in the end, OpenCast Matterhorn, which is focused on lecture capture, was not our use case. And we weren't really needing it wasn't actually really used, the configurability of the workflow. Everyone was pretty much using the same workflow of generate derivatives, drop those derivatives someplace. And it was a totally different stack, and it was a barrier to adoption. And while it served our need, and it had a nice dashboard, it just wasn't working out with us. So we decided we need something that's a little bit more lightweight, that can still create multiple derivatives, that can insulate us probably some from the specifics of the backend, so it can support multiple encoding backends. And with that, we built a tool called ActiveEncode. It's modeled after ActiveJob, if you're familiar with ActiveJob. which allows for choosing different backends using different adapters. This is also similar to Valkyrie and being able to switch out your backends and still have kind of the API be the same. And from this, Northwestern has put their Avalon instance all in AWS and makes use of Amazon Elastic Transcoder, while we at IU are still using Matterhorn for the moment, all within our same Avalon codebase. There's not a big divergence of code around the transcoding pipeline. Okay, so here's some basics of active encode, which we'll go into in the workshop some more. But you can set an adapter. Active encode base is similar to like active job base. You've got a base class that you can set an adapter on for that class. And you can, this is looking at the FFmpeg adapter that we had just recently made. You're passing it a file URL. You're passing it a URL. It could be a file URL. It could be a URL from out somewhere else. And then some options. And it spits back this giant object, which we'll dig into more. But really, like, the basics of it, there's active encode base is this base class. As a class, it provides create and find, and setting the adapter and setting some default options. And then once you instantiate it, you can call create, which will actually, create is different from new in the sense here that create will actually send off this encoding job request off to this external tool, this adapter. And so new will build up that Ruby object instance. Create will actually send it off. You can cancel it. You can call reload, which will just kind of, similar to find, will just fetch and refresh the information. So it's all kind of meant on this like kind of decoupled asynchronous kind of pattern of I kick it off and then it just runs, and then when I want more information, I can call find on it again and get that newer information. So I guess similar to like an active record, stuff happens in the database. When I want to see what's there, I call find and fetch back, and now I have data. And I can call reload on it to do that kind of transaction again. And then some helper methods around statuses to say, is this thing still running? Fields that are available, every encode is going to get an ID assigned by that adapter. It's going to have an input object, which will have information about that input, so like the URL that it was created with, and if that adapter provides functionality, it will return technical metadata about that input object. And then for output, it is similar, just it can be an array. Here's an array of outputs, the URL of that output, so not the actual bits, just the URL to where I can find those, and technical metadata about that output. And I guess on both of those, also some status information of kind of percent complete on the base object, and on the outputs, I'm forgetting if there's percent complete, but there's at least a state saying this output is still running, this output is completed, here's errors on that particular output, here's errors on the input. It's trying to give you all the state information that's possible for a given encoding job. And then it provides a lot of callbacks that you can hook in. So if you were to subclass active encode base, just like you would for an active job, you can now start defining callbacks to say, before I ship this thing off to that external adapter, I need to do some things to prepare it. And so that's what happens with the Elastic Transcoder job within Avalon, is we say, if it's like a local file, I need to ship this up to an S3 bucket. And so I can do that within a before create callback. here's, do you want to do that now, or who has the mic? To Trey. Mm-hmm.
Can I get are the IDs unique to each adapter?
The IDs are, yeah, they're unique to the adapter. The adapter is, the whatever backend that adapter is hooking into is supplying the ID. So there is, I guess, potential for collisions between different adapters giving different IDs.
It works. Or it used to work.
All
right, sorry.
But with each class having its own adapter defined, we also now are generating global IDs that are composite of that class, that subclass, and the ID returned by the adapter. Is that
Yes.
great?
The only other question I have is, it seems based on things like the callbacks and stuff like that, you're assuming that these things are going to spawn like background jobs that it's checking the status on. Is that what the assumption is, or am I just reading the methods wrong? So like current operations, is that like a list of background jobs, or is it?
Current operations would be if that adapter supplies that.
Okay.
And some, so like Matterhorn would say, like, I'm currently creating the high derivative, the high quality derivative. And so, whereas, I'm not sure if Elastic Transcoder provides anything there. I think Zencoder does. Provides some kind of human readable operation text of like, this is what I'm currently doing, as opposed to just as percent complete. Like here's what's getting worked on. And we, within Avalon 6, I don't have a screenshot of this, we have a progress bar for each file that's been uploaded, and it shows that progress, and it shows text saying, like, I'm on this step. So you kind of can tell, like, if it errors out, where it was when it died, or just have some expectations of like, oh, I see it's doing that work now. So percent complete combined with kind of current operation and state and errors will kind of be that information that can be rendered back to a user to show them really like where things are at or where things finished. Percent complete is at this point a little iffy. Not all adapters, all backends will return real fine-grained information on that. It's like Elastic Transcoder doesn't give you feedback on where each output is. So there's some guesswork within the adapter to say, I'm making this many outputs, I'm roughly this way. So at least there's some, it might be chunky, like it's progress, but there's some feedback in knowing kind of where you are in that progress. Whereas Zencoder and Zencoder gives you fine-grained output, and our FFmpeg adapter does as well. In terms of background jobs, you were asking if this is spawning background jobs?
I think I understand now, and that it depends on what the adapter does.
Right. It's meant to not block. It shouldn't ever be blocking the current operation. It should be often a separate thread or background job or running off in the cloud or wherever. Here's what a custom class would look like, a subclass. Just showing this, there's an after create. It just logs some information, and there's this override of kind of the default options, so you can, for a given class, have your defaults that you're always going to be using. You can specify options within your create call, and those will just get merged together. I was talking about adapters and backends. We have this Matterhorn adapter, which is what Avalon was and Avalon 5, I think, was closely coupled to. And we built active encode to try to insulate us from that and allow us to switch. I think now that we're finally have this FFmpeg, local FFmpeg adapter, we're probably going to be deprecating this and really getting rid of it soon. There's this local FFmpeg adapter which we'll be using within the workshop segment. There's these other adapters, Elastic Transcoder Northwestern uses. There's a prototype of Zencoder, and in the future, I guess whatever adapter you want to write, there are shared specs for the adapters to help you in writing them and making sure they all conform. I will say that active encode is preparing for this workshop and these plugins. We've done a lot of work on active encode recently, and we haven't quite gotten to the manual testing of all of these. So the FFmpeg adapter works, which you'll see. The Elastic Transcoder adapter should work. It passes the shared specs, but we haven't actually gotten around to testing it within this new version of active encode, as well as the Zencoder one. But if there's anything, if they don't work, it's going to be just small work, and it's on our board to work on as soon as we get back. Okay, so this kind of wraps up. I guess if there's any final questions, this kind of wraps up the presentation phase, and we'll go into a short break. If anyone has more questions, you can feel free to ask now, or we can have me stop talking at you and take a break. No? Okay. Let's take a 10-minute break. Feel free, get a drink, use the restrooms, and then we'll dive into workshop stuff. I guess if anyone has been working on the Docker stuff and has run into issues or needs help getting your Docker stack up right now before we dive into the workshop, raise your hand or see me or Brian. Okay? Thanks, everyone. Let's just get started. Other people will come back in. So we're going to be working through the instructions here in this repository. We already we went through the presentation segment, and now hope to show you these components and that we've been working on for the IIIF kind of AV side of things, as well as the active encode, the transcoding side. So hopefully you've done the Docker install, you've done the git clone in the repository, and I'm going to run, I just did that just now. I'm going to run the start sh, and if you haven't, if you're not familiar with Docker, you'll see that we have a few containers. This is specific to the workshop right now, but we also have run Avalon in this way of having these various containers for these different pieces. So it makes it a lot easier to bring it up as opposed to where you have to install, before we had installed Matterhorn, which had all its own dependencies, which had dependencies, and it was a nightmare. And so you'll see the Avalon container is coming up now. It's running a bundle install. And Fedora is up, or is coming up. Our database is up. The Avalon container is the one we're going to be working in. This start sh script is just kind of basically a wraparound Docker Compose up. It sets a couple environment variables that we need. And we'll connect to it using this connect.sh script, which does that same thing. It does a Docker Compose exec Avalon bin bash, but there's a couple environment variables that we need within this Docker setup. You got an error. Okay. On the start sh. Yeah. So Brian might be able to help you, but we're just going to kind of keep rolling. So if he can't help you quickly, find someone to pair with.
I never did that. You have to do
Okay. Do Do you need the instructions for re-rolling or unrolling and going through it again?
Yeah, we should
Okay.
probably should put that on our thing.
Okay.
Basically,
Dr. Compose down, Dr. Volume firm,
yeah.
and then we'll start SH again. Hopefully it will be fixed. Dr. Compose down. You see it did the DB migrate, and it's user collection admin set. Are there people able to get their Docker stack up? Let's start SH is going, and you can hit localhost 3000. Okay, great. Mine will be there in just a second. When you do, go ahead and open it up, and you can run through these starting instructions. I'll run through it really fast on my machine. But sign up with archivist1 at example.com. Right now, we didn't attempt to try to debug why within our Docker stack the rake task to generate the default admin set is not working. So we're just going to make a collection, an admin set collection, and work with that. That's finally booting the Rails server for me. And that you'll see as we restart the Rails container, as you bring it up for the first time, it's going to take a while to compile like a few partials and assets. So expect that this will take a little bit longer for whenever we reload that Avalon container. But I guess while I'm waiting for mine to come up, we already talked about this pretty much all from the in the presentation, but just kind of some key points about this plugin, Hyrax-based AV, and what it's doing, which we'll see is it's going to add in this support for Presentation 3.0. It's going to hopefully be backwards compatible with Presentation 2. So if your Hyrax app is already using Universal Viewer, it's already requesting Presentation 2 manifest for images, installing this plugin is not going to break that. It's not going to change that. There's some logic within it, which when we do a code tour, we'll see it. It will do some looking and some inspection of the file set that is going to be operating on and seeing if it's audio or video, and if it is, it's going to try to give you a 3.0 manifest, and if it's not, it's going to keep giving you a 2.0 manifest. And there's some HTTP accept header support for if you want to fetch a Presentation 3 manifest for images, or vice versa, a 2.0 manifest for AV, which would make no sense. But I'm going to do this sign up here. We'll try to show some about the structural metadata and ranges. Talked about using the Avalon IIIF player as well as Universal Viewer. So I'm going to show support added within this plugin to per file set presenter, choose which viewer you want to use. Since Hyrax currently is you use Universal Viewer or you don't. Or you don't do any IIIF. And then shared specs for some of those pieces. So if you want to go off and build your own piece, you can still run the shared specs within your app. Yeah.
At this point, you have a completely vanilla Hyrax instance. Can you create a base work type or anything like that?
Okay. Yes. Good question. So the question was whether within this Docker stack it's just a vanilla Hyrax or if anything's happened to it. And you can look in the repository here. Well, commit history is now a little bit muddy. but all that's basically in that container should hopefully be these, as it pertains to Hyrax, is these 3 commits, where I generated a Hyrax app from a template. I went in and in the Hyrax initializer, uncommented the enable FFmpeg and set it to true. Otherwise, Hyrax will not generate video derivatives using FFmpeg. And I made archivist1 be in the admin group. So, and then I did generate a work type called work. So that should be all that's done here. Nothing else. I think everything else is just pertaining to the documentation in terms of commits. So that's kind of the preview, I guess, of some of what this plugin is going to be doing and what we're going to walk through. So I registered as archivist1, I'm making an admin set collection. I like to name everything with exclamation points. So I have admin set, that's my admin set. And now that we have that admin set, we can create a new work. So again, this is a stock work type, nothing done to it. And if you have files, a video file around to upload, great. Otherwise, you can dig into our Active Encode has within its spec fixtures this fireworks MP4, which I'll be using. It's a small file and it makes it easy, processes quickly. Okay. And this is just kind of setup. We'll take a look at kind of what stock Hyrax gives you when you throw a video file at it. And mine's all running in with the async active job adapter, which is the default. It should be within your Docker container. And you'll see that looks like that just finished there. Here's a logging line of create derivatives job. It's performing it. Again, stock Hyrax, what it's doing is it's using, we'll see this more in the next workshop piece, but it's using hydroderivatives and FFmpeg to generate a MP4 derivative and a WebM derivative. And here's what you first get back when you do that. You get it's processing screen. And if you refresh, after it's more compilation, you should see that it gives you a HTML5 native video player, just a video tag. Try to take a look at that. So you can see here's this HTML5 video tag. It has these two sources, WebM and MP4. And these are just URLs to the downloads controller. Again, the next workshop piece, we'll see a little bit more how the Hyrax Active Encode plugin is storing stuff differently than stock Hyrax. But stock Hyrax will just create these derivatives and actually, let me. if you attach to the Docker container, you can poke around and look and see that if you're not familiar with how Hyrax does derivatives, it creates this derivatives directory underneath temp by default, and it does some kind of like peer tree piece, and using the noid for the file set, and then it generates these poorly named derivatives that have nothing with the original file name in there anymore, and yeah, built onto the peer tree hash, MP4 and WebM stuff. So that's what's coming through within this video tag, and if we try to hit the IIIF endpoint for this, so /manifest on the work URL. Did I misspell it? Thanks, manfest.
What project is that designed for? Is that
Samvera Labs. Yeah, all these repos I'm showing should all be Samvera Labs.
I posted a link to the fireworks thing in the Slack if anybody wants it.
Sorry, I didn't include that in the repository. So here's, yeah, if you can see, here's the presentation 2.0, IIIF Presentation 2.0 manifest. And if you haven't looked at a IIIF manifest before, this is, the bare bone structure of, it's a manifest, it has a label, it has these key value pairs of descriptive metadata. And there should be a lot more here saying, like, here's the content, here's how it's structured, and potentially other services that are available. But you see that there's metadata coming through from stock Hyrax. Like we've got our title, creator keyword, and rate statement. But
can't know that it's a video,
right, presentation version 2, it's taking what information it has, and it has nothing about images or the image content. And so it's not really doing anything with it, except for passing along the descriptive metadata. So this is really not useful as a IIIF manifest, which you'd expect from a presentation 2 manifest. You can see that up there in the context. Okay, so that's kind of current state of affairs. Let's do the workshop piece to pull in the plugin and see it work. So first, open up a new shell if you haven't already. Navigate into your checkout and run that connect sh to connect to your Docker container. Yeah, and so that should drop you into a bash shell within the context of this Docker container. It mounts the local file system checkout. So we're working with the same files that are within that checkout, but within this Docker context. Okay. Okay, so then first thing we're going to do is we're just going to add in the Hyrax-IIIF AV gem into our gem file. If you want to one-line it, here's what you can do. So that's just appending it to the gem file. When we've done that, we'll run bundle install. And we'll see that it grabbed Hyrax-IIIF AV 010. And we've got our gem in. Is everyone good with that bundle install? So Hyrax-IIIF AV comes with 2 generators to try to make life a little bit easier. And the first one is to kind of inject some modules into work type specific classes. And that's going to kind of enable some of this IIIF Presentation 3.0 stuff. So we can run that generator. This is specifying the work type by name, and so the generated work type here is just named work. Wait for it to spin up the Rails context, which always takes a really long time. And hopefully you get something like this. You'll see that it did two kind of inserts, one into the controller and one into the presenter. And if we just look at that, or should just be able to do a diff and see that within the controller, all it's doing is it's adding this Hyrax-IIIF AV controller behavior include. And within the presenter, it's doing a little bit more, but it's doing an include of this displays IIIF AV. This is kind of analogous to the Hyrax module of displays IIIF, I believe is what it's called. But this changes a little bit and doesn't want to conflict, so it's named slightly differently. It's setting the file presenter class, and I'm not super familiar with this Hyrax member presenter factory, so I'm a little concerned if this is like infecting other things by running this, but it's going to say use the IIIF file set presenter, which we'll take a look at, is really just a subclass of the file set presenter with a little bit injected into it. And then commented out, there's this IIIF viewer method, which for AV content, it's going to default to the Avalon player right now. And for image content, it's going to default to universal viewer. And that's partly because Hyrax, since Hyrax 2.1 added support for IIIF, it included universal viewer, and it's the universal viewer that it bundles right now is universal viewer 2.0, which can't handle, these presentation 3 manifests can't handle AV content. So in the future, when Hyrax bundles a better UV, or whether you want to do it, you can flip it to wherever you want. So those are the changes that work type is doing. Now we're going to run this next generator, and it's going to take a while. So we might do some code tour while this is running. This generator is going to install the Avalon player. And this is where it starts doing the React stuff. And I fought with this for a while, and this was the best solution we came up with for now, which is using React Rails and Webpacker. So this is going to kind of bring in a lot of dependencies and stuff. And so we'll kick it off and we'll watch it run. And hopefully, everyone's Wi-Fi and stuff is still running well. When it gets to, I'm not sure if anyone has used Webpacker within newer Rails stuff and Yarn. So it's going to kind of run its own dependency management apart from Bundler, but for JavaScript assets. And that Yarn install where it's fetching, it's just like bundle install, it's fetching all that stuff for React. It brings in a lot of JavaScript dependencies. Thanks. And so we'll let this run. And let's do some code tour while we're letting that run. So here's Hyrax IIIF AV. within the app directory, we have a controller behavior that we saw get injected. And the main thing that it is doing this content negotiation, this handling of presentation 3 manifest versus presentation 2. And when it comes down to it, it's overriding this the manifest action by it adds a header for this content negotiation, and then it's calling super, but super is eventually calling manifest builder. And all this does is saying, you know, if I'm doing a version 3 manifest, call the IIIF manifest gem and ask for a version 3 manifest. So all of the work on generating a presentation 3 manifest is kind of happening within newer changes that are in the IIIF manifest gem that just got a release right before Connect here. But you see that it's separate. It's its own factory. You know, you're explicitly asking for a version 3. You can do that there. It's not going to affect your version 2 manifests generation. My generator just finished running and injecting all that stuff. What we can do is if you exit out of your Docker container, oh wait, sorry, I missed a step. If your generator finishes, or when it does, run this one command, because I need this as a workaround for some of how we're structuring the Docker setup. And it's partly to help Macs, because at least with my machine, Macs and Dockers and lots of files, when they're mounted from the local file system, it grinds to a halt. So this is to deal with the Yarn, like the node modules being often a separate volume that's not mounted from the local file system in the same way. So once you do that and exit out, we'll restart the container, the Avalon container. So is everyone good with getting to that restart? And it's going to have to, turn some more so we can come back to it. It says okay, but we'll see that it's doing more stuff. So I guess I'm not sure if I'm going to be able to do a whole lot of more couture of the gem. Is there additional work for generating the manifest is happening here in the presenters. And you should dig through these and see what it's actually doing. A piece when it comes to the ranges we'll see is sorry, not this one. This include is Hyrax IIIF AV displays IIIF AV, and it implements this ranges method, which, as you see, will call off the file set presenters and collect the ranges from all the file set presenters and bundle it all up here and pass this off to IIIF manifest. And that's what's going to build up your structure. So within Avalon Bundle or Avalon 7 Hyrax instance, we're implementing that file set presenters range. It's not implemented for you here in this gem because it doesn't know anything about how that structure, where that structure is coming from. But if you implement this, or kind of how IIIF manifest works is your presenters implement certain methods, and then IIIF manifest calls those to build up a manifest. So if you implement this range or ranges method in your presenters, then it should show up in your manifest. What was your question?
Yeah, what's a range?
Okay, it's a range is the IIIF language for structural metadata, basically, for navigational metadata. Okay, so that's the ranges part. Kind of flipping back, if your container is back up, that means we can come back to our manifest we saw, which was a little sad, and refresh it. And should make a request, and hopefully now we see we have a presentation 3 manifest. You'll see that the metadata looks a little bit different because presentation 3.0 does all textual labels in language maps. And right now, since we have no information about what language this is coming in as, we don't make any assumptions, and it's just says it's none, doesn't know. Here's our canvas, here's our items. Items, which I mentioned before, was like IIIF 2.0 sequences. Kind of analogous to that, if you know that. Digging down, here's our painting annotation to paint onto that canvas, and we have a choice where the choice of an MP4 or a WebM. So those are 2 derivatives that we saw generated with those URLs with some technical metadata about them. And here's the ranges down here, where right now it basically has nothing, but if we were to implement those ranges, it would show up down here. Okay.
I'm not totally caught up. Is choice hint something that is being talked about and isn't in the spec yet, or what's the?
I believe it's the choice here. I believe is coming. It's from one of the other specs that IIIF is drawing from. I don't believe it's IIIF itself. It might be from the annotations, from web annotations. I think that, I'm not sure if it's talked about within the IIIF spec yet, but this was the approach taken with all the AV content that has multiple choices. I guess that'd be good feedback for the IIIF spec editors if that needs clarification. And maybe we'll be coming later in IIIF, in rolling out 3.0 is supposed to be making a cookbook registry to say it's helpful to see examples, manifests where people have worked on this stuff before, what they're doing, and some of the possibilities. And this should be going into that.
Yeah, it's not important.
Okay.
Talk about it later.
So now we've got a good 3.0 manifest. Hopefully you're seeing this on yours. So we can maybe go back to the work view. And if we load that, then after it does a lot of work and compiling of assets, we'll eventually get the Avalon player there. I think that's. Are there any questions right now or other pieces you want to see within the code of that plugin? This is really going to be kind of like the final step as we see the player and we see it there. I'm not sure if we're going to have time. There's some separate documentation here for customizing the IIIF viewer. I guess we could try and maybe cut down our break. And this shows how, if you want to implement your own IIIF viewer, different from Universal Viewer, different from the Avalon player, how to go about doing that in the way that this gem knows how to handle. And I guess I should back up and say that a lot of these, a number of these changes within this gem are not really specific to Avalon or AV content, especially around generating presentation 3 manifests and choosing your IIIF viewer. So I hope that a number of these things can eventually be rolled back into Hyrax core to allow for the choice of your IIIF viewer. See that hopefully you're seeing this, that it's loaded. You're not seeing the native player, but you're seeing this media element player here instead. You can watch the fireworks. Do people think we should try this right now? Or yeah, Thomas?
I've got a couple of questions. So if you were to have attach multiple videos there, would it have given you a multiple player option there?
That's a good question. I think that's something we still haven't really worked out. I think within Avalon's context, each video we view as its own, each video is its own file set, and we view that as its kind of own distinct player and timeline. We haven't done any work to say, like, stitch those together. If you wanted to have one timeline that represents all of those files together, that would be like a future work thing. And I think right now, all that it's showing is, and I think including in that manifest, I'm not sure what's included in the manifest, all it's showing here is going to be the representation, the first file, or whatever you said is the representative presenter. Yeah.
Then my second question is the manifest 2.0. Is there any concern with backward compatibility with OpenSeaDragon and the image viewer, or anything that you have to worry about there?
Right. So the question was about supporting images and whether this would break backwards compatibility. And how the gem is written right now for image content, for representative presenters that are images, it should continue to just work like normal. And generating a presentation 2 manifest at that same endpoint, and your content should keep working the same. Yeah.
If we didn't uncomment that section, and I think it was the presenter, to select a different viewer other than, I guess it was like universal viewer, how come we got a different viewer here?
So the plugin right now, by default, is saying if it's audio-visual content, if it's audio or video, if the file set is an audio or video, it's going to use the Avalon player that's bundled. That's this React component that this last generator installed within the client app. And if it's image content, it will default to universal viewer. And then if you wanted to do something different, you can uncomment that and hard code or use the file set to choose the viewer that you want.
Plugin kind of overrode what Hyrax defaults to for, I see, okay.
Yeah.
I'm curious also, with this viewer versus what we saw before we ran those tasks, so, I mean, it doesn't look that different. I guess it'll be, the differences would show up more in the file encoded with the different sections and things like that, or kind of like an example on the iView site?
Sure. Right now, yeah, what you do get back is pretty much exactly the same as what you've seen before, with a lot of infrastructure changes kind of underneath. That's just kind of where our player is at right now, but it will eventually, the Avalon player will eventually do that structural navigation links. But you could also switch out, not use our player, and use a Universal Viewer 3.0 build and get Universal Viewer here with AV support. And it's still going to be pulling that Presentation 3 manifest and get same structural navigation and descriptive metadata and all that in the viewer.
At the moment, the main difference would be like a manifest file.
At this point, yes.
Okay.
Yeah. It's future work for kind of building and enhancing this. Do people want to try this exercise to throw in a different viewer? Or if anyone needs a break, maybe come back at the top of the hour. And if people that don't need a break and want to do this can stay, and we can go through it real fast. So yeah. And then at the top of the hour, we'll reconvene and we'll run through the active encode transcoding piece. So if anyone wants to, we can look at, so I just went back into my Docker container, that connect sh in a separate shell, and I'm just showing that what that generator did is it generated this Avalon view partial at this path, app views, Hyrax-based IIIF viewers. And that's going to kind of be the place where these view partials live. The gem still has the universal viewer one. I couldn't supply the Avalon one from the plugin because of the React part and how it all needed to be basically in the client app to function properly.
Would you mind running the microphone? Just like passing it down.
So running through this, we can take, we can make this new file within that directory. Just kind of copy paste this thing in. This is, you see, just doing a heading with some text and giving a link to the manifest. And what did I call this? My IIIF viewer. And then to make the file set presenter use it, we can edit that, or sorry, the work presenter. We can uncomment this method and change it to the name of that, that same kind of partial name that we were using. Now to have this show up, we'll need to restart the Docker container right now. There's some code reloading issue that sometimes breaks. So I just restart the whole container. And once it eventually comes back up, then should be able to flip back over to our work, reload it, and we should see that other viewer pop up instead of this Avalon viewer. And hopefully you're seeing something like this.
Got to restart Docker.
Okay, yeah. So it just has a spot for that partial there now, and kind of whatever we want to put in there. And so now this provides a way for you to flip out and not use universal viewer.
Kind of
You can,
hold that space and put in whatever you need.
yeah, you can kind of choose, and it's choosing per work presenter, I guess. So if you say you want those images, that postcard collection, you know, to still have this version of universal viewer, and say like on this other work type, you want to use this other presenter, then you can, or other IIIF viewer, you can do that. So we did the kind of Hyrax IIIF AV and looked at the Presentation 3.0 manifest and the Avalon player, ability to switch between IIIF viewers. And next step is we're going to go into the transcoding and look at Hyrax active encode. So I'll start by just firing up the connection to the Docker container again, and dropping Hyrax active encode into our gem file, and running bundle install. This time we should see it pull in Hyrax active encode, and let's do a bundle show to see which version of active encode it pulled in. Okay, it pulled in 0.4, and I actually just pushed something last night. So if you could do a bundle update active encode, just so we know we're pulling in the latest active encode version. So again, after you've dropped that gem in and run bundle install, do a bundle update active encode. And that should, I didn't do the conservative. So it's pulling in some other changes, but it will pull in the newer active encode as well. Hyrax active encode gives us one generator, which is just going to do a pretty small thing, include another mix-in. So we'll run that once bundle update's done. It's compiling. Okay, there we saw that it's pulled in. We're just back up here. Active encode 041. So that's the version we want to have. We'll run this generator.
What's the idea behind the dash and the underscore?
Yeah, so I think that's just the pattern that Drew and I have talked about some of just Hyrax plugins, to have them, this naming convention of Hyrax dash plugin name, and since the otherwise in Ruby we try to do like underscores, so the dash kind of separating like the Hyrax and the plugin name
itself, yeah.
plugin using underscores.
And that's what dashes are colons? Yeah.
Oh.
Dashes are its own namespace? Yeah.
Okay, dashes go to colons. That's a good way of describing it. That's why you hear the generators trying to follow the same pattern. So you see this dropped in something in the file set. Let's check out that one change. It included this file set behavior and indexer. And we'll see why we're doing this because of how we're deciding to persist information about derivatives. Excuse me. So I'll work on some code tour while we'll let this reload. What we'll do is we'll drop out of the container and we'll do a restart of the Avalon container. No, outside of it. Yeah. And what's happening here in Hyrax active encode, what it's actually kind of overriding or doing differently than Hyrax is it's adding a different derivative service. And Hyrax right now has one derivative service, the file set derivative service, but it has a the derivative service, there's a derivative service class which acts as a factory for choosing which derivative service to use for a given file set. So what we've done in this plugin is to prepend our derivative service into that list. So, and then there's a valid method, which is, you'll see here, and it's basically saying if this file, this derivative service that's provided by the plugin will run if it's one of the supported MIME types, which is audio or video, and if that file set also includes this behavior that we just saw. So it's going to be pretty narrow. It's going to say only for these things that you've asked this derivative service to run, and just AV content at this point, because all Active Encode does, run this derivative service instead of that stock Hyrax one. And if that valid returns false, that's fine. It goes on and does the file set derivative service just like Hyrax normally would. And what this is going to do that's a little different than Hyrax's one is it's still going to call hydroderivatives. Hydroderivatives has a runner, I think is the correct term, for Active Encode. That with the work of Valerie from DCE, we had built in some support on hydroderivatives for Active Encode. The separate runner, so just like the image runner versus the video runner, it kind of stands on its own. And that's this Active Encode derivatives here. And if we dig into hydroderivatives, go into lib, hydra, derivatives, runners, Active Encode derivatives, we'll see that it's using the Active Encode processor. And if you're familiar with hydroderivatives, if you're not, this might not be too important. But if you are, you may have been in here in the processors and seen how it calls out to FFmpeg, or it calls out to ImageMagick. And the Active Encode processor will, basically here in process, is it will call out to Active Encode. It takes the encode class, which is either Active Encode base or what's passed in, and it will call create on it. And then, like the other processors, it either blocks and waits. Hydroderivatives blocks and waits until that forked process finishes, which is a little different than Active Encode, where you kick off something and you come back and ask for more updates. So this is still following that hydroderivatives model. And it waits, and the waiting, you can see down here, is doing some sleep polling, and then it takes that encode job, it runs that reload, and checks if it's running, and keeps sleeping. So that's the blocking approach of hydroderivatives. So when we get done, what? We're going to change that?
Have progress bars and stuff currently.
Hey, say that again?
How will you run your progress bars on this?
Yes, that's a good question. We'll get to that, I think. I guess Hyrax runs all of this within background job. So that's why when it blocks, it doesn't block your main stuff. On line 25, we see at this point the encode job is complete. We check its outputs. For each output, we call the output file service. And this plugin will provide an output file service, and that's where we start seeing how it stores things a bit differently than stock Hyrax. So let's see. And what this plugin will turn on is this persist Active Encode derivatives, which is its output service. And before we really dive into this, let's just see it in action. Our container should have reloaded with the Rails container up. So go back to your works dashboard, and we'll add a new work. This has to, because we restarted the container, it has to recompile the assets and partials, and it always takes a while. So I'm going to re-upload that fireworks and try to watch what's going on over here. It won't look too much different in the console when it eventually gets to that create derivatives. And the fireworks video from the active encode spec fixtures. If you try to add the bars video from the spec fixtures, it won't work right now because FFmpeg doesn't like it for some reason. But if we did that, we could see what errors look like. Okay, it's still running. We've at least gotten this screen, and I'm not sure if it's actually run the derivative generation yet here. Looks like it may have. Okay, I'm going to assume that it has. And if I look at the manifest, you should see now that same choice, but you'll notice that these URLs are a little different. That they still are pointing to the downloads controller, but they've got these different file names. This is kind of like the evidence that it's doing the same thing, but through active encode instead. So by default, within this plugin, it's going to build the exact same derivatives and place them at nearly the same place as stock Hyrax would. The only thing that's different is the file names slightly different. But it's still, by default, we'll be dropping these derivatives into that derivatives directory on disk. So how is this really different from Hyrax? We can look at this output service that we paused on and see that what it's going to do is this, since active encode could hand you back a URL that's remote, it's not a local file. What it's first doing is it's checking if you pass the local streaming directives. This is a directive here is one of the options passed into hydro derivatives. And this plugin, as currently configured, I guess we can go back and look at that. Let's go back and look at the derivative service. So the derivative service right now is calling create. It's passing in some options, and for each output, it's setting these options. By default, you can change the defaults, but it's going to set this local streaming true to pass it along. So this is basically saying, put the derivatives where Hyrax expects. Don't do any external streaming stuff. Don't try to do that. Just drop them in the same place. This is a configurable option here. And flipping back to here, we're trying to handle that local streaming to say, move that derivative, copy it. If it's a local file on disk, then just move it to where the derivative should be. If it's URL, try pulling it down and dropping it at that place. and set the output URL to the Hyrax download path. Now, Hyrax, the next thing it does is what I'm going to talk about, is Hyrax's output file service that it uses will drop those derivatives on that place on disk, but leaves it there. It doesn't do anything in the file set to record that it made derivatives, that derivatives actually exist. So there's nothing stored in Fedora. It's just, here's downloads URL, or just convention. It's just expecting those derivatives to be there. So now that we're saying we might have multiple qualities, we might have different things, we want to actually record information, including like if it's an external URL, if it's streaming from some streaming server, we need to know that, and we need to be able to save that in Fedora, as well as maybe technical metadata to say, here's your choice between the high, medium, and low. We need to be able to tell the user what are the differences between those. We need technical metadata. We need to be able to store within the file set a file that represents this derivative. So that's what this output service is starting to do. It's going to, within that file set, it's going to call build derivative. And that's part of that include that we included in the file set. And it's going to set some information. You can see it's setting the content to empty string. It's just, all it's trying to do with this file is set this metadata. And right now, as I said, technical metadata, right now that's not implemented here yet, but it will be. Active encode's returning that, or if the adapter is returning that through active encode, we're going to try to capture it and store it here. So let's try looking at this within the console. Connect back to the container. I guess, is everyone able to generate those derivatives when they went back into? Yeah.
Video again after doing that, and it seems like you can't find the derivatives. I'm just curious, in your instance, are the thumbnails showing up properly?
Right, I did not get thumbnails or.
It's a good point. Thumbnails are not there yet. With the active encode options are generating video derivatives, but aren't generating thumbnails yet. That's something we hope to add. We hope an active encode is supposed to be passed off a video file and receive back whatever derivatives were requested. So it's sort of similar to hydro derivatives. And so you should be able to request a thumbnail, a poster image, a sprite map or something. And if your adapter supports that and it returns it back, you should be able to receive it and save it. So right now, all that this plugin is really handling is the video derivatives at the moment. So it's future work to do the thumbnails and poster. Is that?
Can you quickly go back to the manifest to see and point out how many of those working?
Sure. What you'll see different is the ID here in the choice. It's going to be to the downloads controller still, but it's going to say your file name and not just like the hash. Yeah. It's not going to just be single character dash mp4.mp4, which it would, or no, it'd just be file equals mp4, I believe, previously. So I was just going to, the next place I was going to go is into the container, and let's inspect this file set within the console. So I'm just doing RailC. And after connecting to the container, I'm going to grab this work ID. go from there. So I can do this just to pull back my work. File set equals work.file sets at first, right? Because we just have one. And then file set dot files, we should now see there's 3 instead of just the 1 original file. File set derivatives will return us just the 2 PCDM files that are derivatives. And how it's doing that is the PCDM use for these derivatives is service file, I believe. And then it also has, that might be it. We can take a look at that if anyone's really interested in how it's selecting the derivatives from the files specifically. And there's this other method, derivatives metadata, which is making this kind of JSON, or is making an array of hashes saying here's the ID, here's the label, here's the external file URI, and then that's getting pushed into Solr to be used by presenters and things. So this is how we've taken the approach to storing derivatives, and that's what the plugin is doing. That it's creating files within the file set, storing some metadata on those with empty content. There's other approaches within Fedora 4 and within Fedora 5 for how to do the same sort of thing of external URL. And so I guess if you're going to the Fedora 5 workshop in the afternoon, hopefully they might talk about that. And it's different between Fedora 4 and Fedora 5, how they're handling that external file piece. The approach we took is, I don't know, just kind of a hands-off, we'll just make a metadata field and have an EBU core locator, just a property, and store that URL there and not expect any special handling of it. And just kind of wait and see if we want to really adopt that or not.
If it helps, we have a non-Hyrax-based thing, and this is practically exactly the same as what we have.
Great. That does make me feel better. I guess.
So,
yep.
So derivatives and derivatives metadata, that's coming from.
It's coming from the plugin.
Coming from
Yeah, that's not stock Hyrax. That's our kind of opinion that we're asserting within the plugin. And we can see, so for that PCDM file, to be able to store those things, we have to add those metadata properties through Active Fedora's process of registering new properties within a file. So if we look at one of them, here's the first derivative, and derivative, here let's do a which derivative resource dump TTL. Come on. Oh, right. Doesn't have a resource. It has a metadata node. Okay, here we go. So here's the RDF that's getting stored on that file. We can see that it does have that PCDM use service file to identify it as a derivative as opposed to original file, which is the PCDM use for the originals that you upload. And then it has down here these EBU core, EBU core locator. is what we've kind of added here. The label is just coming through with, I forget which property is getting used. But so there's, I guess, showing that our file, PCM file is a little bit different. It's injecting that it was extra fields, and we're going to inject more when we have that technical metadata. Although some of those technical metadata fields might already be available. Or they should be. What?
It's not hanging off of the file.
Hanging off of a file. So now our file set has original file plus a file for each derivative. Storing derivatives differently. Okay. Then my viewer is not showing here because this is following on from the last segment where I made a custom viewer. Let's go back to these instructions. So we did all of this. We touched on storing derivatives, storing technical metadata about the derivatives. It's getting indexed. Showed how it called active encode. Let's do some configuration. Let's do some customization here. And then we can come back to progress bar as part of that. So there's this separate kind of markdown file within the repository called customizing encoding. So if you want to pull that up, you can, we can try to follow along with that. So I was showing how in active encodes derivative service that we stuff some options into this options, the outputs within the options hash that's getting passed off to hydro derivatives. We took the approach of having a service class that you pass the file set to build up your options as a way of customizing this. So they're saying the default one is provided by the plugin, which builds you the same audio and video derivatives as stock Hyrax will right now. But if you want to change this and say now, instead of Hyrax's WebM and MP4, I want to build multiple qualities of MP4s, because I only care about MP4s. I'm going to be streaming this. It's going to come through media element or some JavaScript player, which is going to handle that stuff, and I don't need to worry about providing all of the derivatives for all of the native browser experiences. So that's what we'll start with here. Within, so we'll drop out of the Rails container within the Docker container. I'm still in the Docker container, and I'm just going to copy this file over into app services. So vim app services, is that there? Sorry, app services doesn't exist yet, so let's make it. And then we can call it my option service. And then I'm just going to copy paste all of this. And we'll take a look at it here. It's basically, it's taking a file set and it's just building up this this array of outputs that is in the style that active encode wants to see. So these options here, label, extension, FFmpeg opt, are specific to the FFmpeg adapter. Something we're still working on is trying to figure out how to make the options passed in for generating derivatives be maybe slightly more standardized or between the adapters. There's a possibility of not doing this here, but rather within the active encode-based subclass. We haven't really explored that, but that should be possible, since we have that default options available within the active encode base subclass. And you can see for this one, we're going to build a high and a low, and we've got different dimensions and bit rates. So close out of that, and to enable this output service, I'm going to add this line to Hyrax initializer. Just at the bottom, it's fine. And all this is doing is saying, for this derivative service, prefer this option service class. And it's done this way because how Hyrax works right now, when it calls derivative service, the factory to spawn a new derivative service for the given file set, there's no point in there to inject any customization. So that's probably a growth point, something that could be changed within Hyrax to try to make it easier to invoke with new stuff. But right now, Hyrax is creating the derivative service for a given file set with just the file set. It's not passing anything else along. So this is just a way to kind of inject that default in at that point of initializing the new service. So we've made the option service, we've put in the initializer. Let's yet again restart the Avalon container, and if we put in a new file, we should see that it generates two MP4s, a high and a low, within that manifest. The Avalon IIIF player currently does not allow the user to select quality, but that's something we're going to be adding because that's core functionality for us to be able to switch between those. Also, the kind of future work within that is adaptive bitrate support to have, say, like an auto quality where the HLS manifest that is provided back will wrap this HLS manifest for the 3 quality derivatives or how many quality derivatives, and then based upon bandwidth, it will select which one to use. As you get more bandwidth, it will choose the higher one, and if you get less bandwidth, it will choose a lower one. You probably have seen how that stuff works. So if you were able to do this, add that option service and restart your container, then we go back to the works dashboard and add a new work. We can see that it follows through and generates those different derivatives based upon our new configuration options. The Avalon, the Avalon player, Avalon IIIF player, like view partial is within the Hyrax IIIF AV plugin, which just loads the React component. The React component is actually provided from an NPM package, but that NPM package is backed by a repository that I believe is in Avalon Media System. Yeah, it's in Avalon Media System GitHub org. It's confusing because I know there's other ones that were in the process along the way. I will get that. I will look that up and get that for you. Whichever one has the most recent activity will be the one, unfortunately, at this point. I believe it might be named React IIIF player. Yes, is that? Okay. Sorry, we haven't cleaned up our old repositories. Okay, so here we are. creating a new work this time. Should hopefully be getting two qualities, two MP4 qualities. I need to add the file. And it's off doing a bunch of stuff, and it will eventually call a create derivatives job. Active encode will get called. I'm going to connect back to the Rails container. And I'll watch and wait to see those derivatives show up in that Hyrax derivative directory. So we see we got these new derivatives here, and it's in the temp derivatives directory, and we see we have a poorly named files. I apologize. It's due to Hyrax at this point. But the file names look really funky. But this is what works as a derivatives, with the downloads controller. But we see we have a fireworks high, a fireworks low. So we made two different files, and if we do a, let's see, media info is installed. So if we do media info on these, which is media info is a tool to just get technical metadata about a file, specifically AV content. You can see that this is a 640 by 480, like we expected, and the low, is a 320 by 240. So generally there's two different derivatives for us. We changed that option service, and we got the different stuff. Any questions about that point, or you move on to customizing the active encode base subclass?
Other questions?
Yep. Oh, we have 15 minutes, so I guess we could go on to doing the active encode base subclass, or if people have a lot of questions, we can just break for questions. We can maybe just not do this point. I can talk about it in 5 minutes, and you can run through it later, and then we can have questions. We do that. Some of the potential of active encode is to be able to define your own subclass where you do special things, you add those callbacks, and then to inject this into that derivative service we saw, and have it. I would really use more of active encode. So I didn't talk about these two modules that we've included in active encode as optional right now. One's polling and one's persistence. The polling plugin will add an active job, like a background job, that will call find and provide more callbacks. So it provides an after status update, after completed, after finish, after error, because those weren't really possible before, because we were just, whenever we request update from active encode, then we get information. We don't know when it's completed. It doesn't tell us when it's completed. We have to request that. So this polling optional mix-in into an active encode-based subclass will do that polling for us and provide new callbacks. The other include here is persistence. And it's again optional. That active encode base comes with an active record model that will just capture kind of the raw output, the JSON serialized form of the active encode base class, and some status information, and we'll dump into the database. And it will do that whenever find or reload is called. So whenever you request stuff from the external adapter, it will effectively cache it locally. And part of the reasoning for that, we wrote this, is thinking of these external services as encode jobs being ephemeral, that at some point, Elastic Transcoder will start garbage collecting our old encode jobs. We won't be able to request something from 100,000 encode jobs before it will have expired, and we won't be able to get any meaningful information back. So by dumping into a database locally, we can now build a dashboard that will eventually, we can continue to share that information. So mixing these two together means that there's an active job running that will, every 10 seconds by default, we'll call find. Since find is called, it will get cached to the database. And the hope is from there, the future work is that we'll be able to build not only a dashboard, but progress information. Is now that we've stored it into a database with an active encode, which is now an engine, we'll provide an endpoint that will just be able to share that information back out to JSON information. And the Hyrax front end, maybe a React component, will hit that endpoint, get that JSON status information, and be able to power a progress bar. Yeah, so now that's like the quick of like what these pieces and how we get to progress bar, and also how you define a custom encode class and get it used within this plugin. It's basically the same as that options class, just for the encode class. So yeah, so questions? Go for it.
So when the active encode is saved to the database, do you keep it forever, or is there some point at which you don't really need that anymore and then you have some cleanup operation?
At this point, we haven't gone that far yet. We haven't actually built those pieces yet, so we haven't figured out what our policy might be on that. In terms of experience we've had with Matterhorn and its dashboard, is that after a lot of encoding jobs over 5 years, the database has become unwieldy, and we have gone back and cleaned stuff up. But with Genu, it's a manual script to just go flush it whenever we feel like we need to. It's optional here for that reason, sort of. It's like if you want to power those things in the future, we'd have that. We could provide a rake task to do some expiration if it's unwieldy. But we haven't determined what the right mix for that is yet. Anyone else questions about Hyrax active encode or anything, since this is our final 10 minutes?
Sorry, just a follow-up.
Yeah.
Is it on?
I think it is. Yeah.
Once you have the complete status of the job, you don't really have any more information you're trying to get out of it. Is there something else in the active encode project that you might still want after all the derivative creation is done?
Once all the derivative creation is done, and like the hydroderivatives output service, in this case, has consumed it and persisted information and copied the derivatives or moved the derivatives off to where it expects it to be, there isn't probably much that you want to operate on, but you probably still want to see the status of that encoding operation still. So especially if there's errors, of course. John Cameron, who's not in the room, he's our service manager as well as our PO, service manager at IU, and he does a lot of these uploads further and helping people with uploads to Avalon. So he spends a lot of time going back to this dashboard of Matterhorn and seeing, like, is that done? What's the status on that? Is there errors? And having to check back over time. So I guess maybe this is somewhat analogous. I think of it as analogous to any kind of active job adapter that might provide a dashboard. So like we're currently running Rescue, and Rescue has like Rescue Web, I think. That'll give you that view onto that information.
Yeah, in fact, I think I've seen this done, if there's not an error status, like it's just gone. So we don't see it in the dashboard anymore.
Yeah, and I think we've taken more the approach of hold on to it so we can still see that for now. I think, but I think we're definitely gonna have to think about.
Like, you might want something like,
You might want to see like how long it took to run, or yeah.
Right, and I guess the time it takes to run is not information currently captured by active encode, but it very well could be. A lot of adapters provide that. Or sorry, a lot of external services provide that. It's not currently implemented in the adapters yet. But again, that's something that we're kind of somewhat thinking of what were the features that, at least at IU, that we used within the Matterhorn dashboard. And the Matterhorn dashboard did provide that information of like each operation, how long it took, and this kind of performance.
Or even
Data.
just to help with cleanup, it might be nice to have a timestamp of when it did finish.
Timestamps are definitely there in active encode, as well as persistent to the database. But the time to complete, I guess I think it's computed at this point. I think from last update and created, you can get a rough feel for that. Anyone else? Questions? I mean, if not, I guess I just want to say thanks for coming. And of course, with these plugins, we're making these under the Samvera Labs organization. And while the Avalon team is building them right now, we need it for Avalon, but we also want other people to use them, especially, say like active encode. We're trying to put a lot of effort into active encode, so you could even use it outside of hydro derivatives if you want. So yeah, pull requests are definitely welcome, and feedback, and however we can help support use of these tools and yeah, make them better. Yeah, sure, yeah.
Sorry. I saw that your IIIF AV thing does content negotiation on those MIME types. Is that agreed upon?
I mean, the spec, the spec, it's the IIIF presentation spec doesn't say anything, as far as I know right now, about how to support the migration from 2 to 3.
Okay.
And those accept headers was, I think, what was sort of some people consensus upon as the best approach at the time. But that's just a few people like in Slack, I think, and maybe in some GitHub issues. So I think that's definitely not set. I don't think, I guess I'm still, I don't know if the IIIF spec editors have, or community has come up with any like formal or semi-official like migration path documentation. So that might change. We might change the implementation based upon whatever comes out of that. It's really just kind of how to support this transition from 2 to 3 while keeping the URI of the manifest the same, because otherwise, like, what's the point, sort of. So I guess if you have really good suggestions,
No,
talk to John.
yeah, I thought that was, we have an open ticket that is the same thing, and I was hoping that you had a solution.
So this is what we saw as people talking about and feeling like the best. I know I haven't necessarily seen John Stroop talk about it, one of the IIIF editors. I'm now all of a sudden blanking on who it is, but some of the other IIIF spec editors have been thinking about that and talking about it more. Yeah. Thanks everyone for holding in for the 3 hours. It's long.